model.
Okay. So events we'll discuss later. Today we'll start with the interface. Okay. So what is mean by an interface? What is mean by interface?
Ma'am, connection between blocks.
Okay. Connection
Interface is
between
a
which
bundle of signals.
Blocks or any design.
okay. So interface is nothing but we will connect a design with the test bench, right? That is nothing but interface. Is
Okay,
it
ma'am.
correct?
Yeah, ma'am.
Yeah. So we will connect a design with the test bench. Suppose if you see in Verilog HDL, so in Verilog HDL, how we will connect a design with the test bench? In Verilog HDL, how we will connect our design with the test bench?
Using nets, wires.
Okay. So there we will write the DUT, right? DUT port list. So whatever the port list we are mentioning in the design, same port list we will mention in the Verilog test bench also. So where inputs must be declared with reg data type and outputs must be declared with var data type. So we will write that thing and we will do the interface between design and the test bench, right? But in SystemVerilog, what is happening? There is a architecture. So with the architecture, we need to connect, right? So here, same like Verilog, we are using the interface here. So I will explain you detailedly. So if you observe, this is how in Verilog HDL, we will connect our test bench with the design. If you see a simple example, like any example, suppose here is a demultiplexer program. Okay. So what are the input signals in the demultiplexer? So here 1/8 demultiplexer using 1/2. So finally, what are the inputs and outputs? Input 1, selection line is also a input and the output out. So here, so inputs must be declared with a reg data type because the inputs we are using in the procedural assignment within the initial block, the inputs must be used as a LHS side, right? So LHS means we need to declare with the reg data type. So same inputs we are connecting using a DUT. So name of the design DUT and its ports. So this is how we can interface our design with the test bench, right? So, but is it same in SystemVerilog? In SystemVerilog, we are not interfacing directly like this. Okay, so there are a bundle of signals. So parallelly, we will interface the bundle of signals to the design. So if you observe here, the test bench, so how we are considering the interface here and the design. Okay, and also, so here interface is the name of bundle of wires. The interface aims to encapsulate the communication. So mainly it have the directional information in the sense whether those are the inputs or outputs, and also it have the timing information with respect to the clocking blocks. Okay, timing information in the sense. So here with the if you remember the SystemVerilog test bench architecture, there will be a driver and there will be a monitor, and here there will be a generator and there will be a scoreboard. So from the driver we will connect our test bench architecture to the DUT via interface. So from the DUT the data will be get to the monitor. Okay, so while connecting the driver and driver and monitor to the DUT, we need to check two things. One is a mode port connection. ports connection. Another one is a clock connection. Clock connection in the sense driver may work at some clock and monitor will work at some clock. The synchronization is very important between the both to avoid the setup and hold time analysis, right? So here we are considering the skew analysis also. Okay, so we are mentioning the clocking block and mod port in the interface. Okay. So next thing is, so this is the syntax for the interface. Interface, name of the interface, and within the interface there will be interface items and interface. Okay. So what are the advantages of the interface over the traditional connection in the Verilog? So here it allows the number of signals to be grouped together. Okay. So instead of taking single port signal, multiple signals will be taken in a group connection. Okay. So it is easy to use delete the method or add the methods. Okay. So this is how the normal traditional method in the Verilog, just whatever the input and output data are there, in the test bench, we will consider as a reg data type and wire data type. In DUT, we'll write the instance of that design. Okay. But in the SystemVerilog, what happening means, here we are creating a separate interface block. Okay, separate interface block like this with a name some interface, and we'll write all the inputs and outputs here. Okay. Okay. Next thing is, if you observe in Verilog HDL, whatever the input and outputs are there will declare as a rich data type and wire data type. So, but SystemVerilog, we have a new data type called logic, right? So, can you tell me what is meant by a logic data type?
So instead of like using both net and reg, wire and reg in Verilog, we like in SystemVerilog we have logic, which is like 4-state data type, which can represent 0, 1, X, and Z.
Okay. Yeah. So in SystemVerilog, there is a rich data type for procedural assignments and wire data type for continuous assignment, right? So when there are 10 number of inputs or small number of inputs means we can easily write what are the reg or their wire. So sometimes if there are complex number of inputs and sometimes in design it would be very confusion when to use the reg and when to use the wire, right? In test bench also. So in that case, we use the logic data type which replace the reg and wire. Okay. So in place of reg and wire, we can simply put the logic data type. So based on the port connection, it will consider what are the inputs and what are the outputs. So that is the new data type in the SystemVerilog. Okay. Everyone clear up to here? Everyone clear up to here?
Yes, ma'am.
Okay. So,
Like,
yeah.
ma'am, like in port, if you define our the pins input and output, so logic data type will treat them as wire, right?
What? Sorry. Import?
Like if we write logic clock, so how it will take it is raise or wire.
Ah, so here how it will take in the sense in the test bench, this is only interface. Interface in the sense just we are connecting our test bench signals to the DUT. Okay. But in the interface, as I mentioned, we will write the mod port connections. Okay. Through the mod port, we will mention what are the inputs and what are the outputs. Like that through the clocking block, we will mention what are the input and what are the outputs. Okay. And also in the test bench top level, we will connect with the input and output. So all the things I will show you. Okay. So like that, suppose if you observe here in the same example. So in the design, there are clearly mentioned what are the inputs and what are the outputs. This is the top level test bench here. DUT. So here we are mentioning what are the input and what are the outputs. And in interface also there will be modput and clocking block, which can be easily defined what are the input and what are the output, and that too in the transaction class. In SystemVerilog we have the transaction class, right? There also we'll mention what are the inputs and what are the outputs. So based on that based on that it will automatically know what are the inputs and outputs. So if you observe a example, suppose here is a design. Okay, so here you already know, I think we already discussed it in the Verilog HDL about the calculator project, right? So in the calculator project, if you observe what are the inputs and outputs, so here outputs, it's a 4-port calculator. So output data 1, data 2, data 3, data 4, output response 1, 2, 3, 4, output tag 1, 2, 3, 4, like that inputs request one command in tag signals, data signals. So based on the design top level, we have clearly mentioned what are the input and output. Okay. So how we are interfacing this design with the test bench. So coming to the interface. So in SystemVerilog, you already observed, right? What are the different blocks like generator, driver, monitor. So at the starting session, I have explained every block. So how the every block is connecting. So like this, we will write every block, generator, driver, monitor, scoreboard, environment, everything. Okay. So in that interface, whatever we are discussing the topic here about the interface. So interface is a separate component here. Okay. Um, so So if you observe here, the interface block, this all block is for interface. Every program, if you take any design of Verilog HDL, even if you are using system Verilog UBM, any program is same format. Okay, format is same, but internal logic would be different for generator or driver. According to the functionality, internal logic will be different, but everywhere same format, same syntax. Okay, so that's why hands-on experience is very important. Okay, so whatever we are writing the program here, after the session, try to write every program. Assignments are very important. Whatever I have shared the assignments, those are very important. So please try to write the program for each question. Okay, don't copy anywhere. Try to write, even if you want to copy, you won't get the answers because those are designed by own. Okay, so if you practice those things, definitely you will get good coding knowledge in SystemVerilog. Okay, so observe here how we are writing the interface. So interface is the keyword. We'll write the interface. Here only interface is a normal keyword. Remaining all a generator or driver, all these are classes. Okay, class driver, class generator, class monitor, class scoreboard, but except interface, even transaction also class only. Test is a program. So in Verilog, in SystemVerilog, we have the program block also, and the test bench is normal module. Okay, so you need to understand the difference. That's why I'm telling. So main difference is interface is not a class. Okay. So interface, calci if is the name of the interface. So here we are passing the arguments, the clock and the reset, and remaining all are like a command in signals or data in signals or tag in signals or even output signals we are mentioning with a logic data type. Okay, no need to mention its own data type like a bit or byte or integer. Those things will mention in the transaction class. Okay, so in the transaction class, what happened? So where there will be a transaction class, whenever we are sending the data from the generator, driver is there, and there is a monitor, and there is a scoreboard. Generator to driver, we are passing the randomized data. right? Like that, from monitor to scoreboard, we are getting the data, input and output. So what is this data which is mentioned in the transaction class? Okay, so the transaction data we are randomizing, same transaction data we are sending to the DUT. Okay, so same transaction data we are putting into the mailbox from the generator and sending to the driver. Through the driver, we are accessing the data from the mailbox. Okay, so same here also, from the monitor we are putting the data into the mailbox, because mailbox is the communicator between the two components. So here from the monitor we are sending the data to the scoreboard. So that is the transaction. So where the interface is coming? Interface is coming at the DUT side. While we are connecting with the test bench to the DUT, here interface is getting. So try to understand these things. What is the transaction class? What is meant by interface? What is meant by mailbox? And where we need to use and which one we need to use. Most of the people will confuse like, so in the transaction class we use the rand. Most of the people will put this rand in the interface and logic in the transaction. Okay, but you need to understand where we put the rand and where we put the logic. Okay, why we are putting the logic? For connecting to the DUT to the test bench without using the reg or var data type in the interface, we are using the logic data type. But no need to use the logic data type in the transaction class. Okay, so here why we are using the rand here? Because this transaction data is going to be randomized, right, in the generator class. So in the Verilog HDL, for randomizing the data, we just use the $random. Right, so any variable, suppose if you take a data input, so data input equal to $random, tag input equal to $random, command input equal to $random, right? But here we are not using $random, it would be a bit complex. Just we are using a method, okay, randomized method we are using. So when the randomized method will work, whenever the signals are declared with a rand data type, then the randomized method will work. Okay, here if you observe, for outputs we are not writing any rand. Only for inputs we are writing the rand, because only inputs need to be randomized. Outputs no need to randomize, right? So that is the difference. Okay, so in the transaction class, we'll declare the inputs and outputs, but inputs must be declared as a rand data type, because those inputs are going to be randomized in the generator block, and from the generator block we are putting into the mailbox. Yesterday you have seen the mailbox methods, right? So how we are putting the data into the mailbox and how we are getting the data from mailbox to the driver. Okay, so in the driver we get the data. That data we are sending to the DUT via interface, via virtual interface. Okay, so this is the flow. Okay, everyone understood up to here? Hello. Hello.
Hello.
Yeah. Is there any
Ma'am,
Yeah.
yeah, already we are connecting the blocks by mailbox.
Hmm.
Then why do we need transaction class?
See, mailbox is just a communicator between the generator and the driver. Mailbox is not generating any data, or it is not doing any randomization. Okay. So it is just taking the data from the generator and sending the data to the driver. Why we are using the mailbox or FIFO or any, if you go for UVM, there are some protocol like a TLM ports. So why we are using these things between generator and driver, or any between two components? Because of synchronization purpose. I already told you, right? So if generator is generating 10 number of transaction, driver is able to receive 10 number of transactions properly without any loss of data. Loss of data in the sense, generator is sending this 10 number of transaction in 1 minute. Okay, but a driver is working with each single transaction. It is taking 5 minutes to complete one transaction. It is taking 5 minutes or 2 minutes. Okay, so if generator is sending all number of transaction in 1 minute, but still driver is performing each transaction in 2 minutes, what about the remaining data? So it will accept only one transaction, and last 10th transaction it will accept. What about remaining all middle transactions? So there will be data loss, right?
Yeah, ma'am.
So without data loss, what we are doing here, temporarily we are putting all the transactions in the mailbox. Temporarily we are storing there. Whenever the driver required one by one, it will access from the mailbox. Like FIFO also same. Okay, but FIFO or queues we use within the component. Okay, but mailbox can be used outside one component to another component. That is the difference. You will get the interview question like what is the difference between mailbox and FIFO or mailbox or queues? What is the difference between? Those will work within the module to module, within a one class or one component. Module to module it will work, but if you want to communicate with the two components separately, we use the mailbox. Okay.
Okay, ma'am.
Others, did you got
Mailbox
the
we will use to avoid data loss,
hmm?
right?
Mailbox?
Mailbox we will use here to avoid data loss.
Yes.
Okay.
Okay. So that is what difference between transaction interface and the another thing I will show you. Suppose here there are how many number of signals? 12 number of signals are there. Okay. So in Verilog HDL, if you want to randomize these 12 number of signals, what you will do?
$random.
Dollar random. Okay. If you write dollar random for one variable, is it enough or we need to write for 12 number of variables?
For 12 variables, we have to write.
12 variables we need to write. Okay. But in SystemVerilog, because of we are using the class-based verification, because of object-oriented programming, so for this class, we are creating an instance called object, right? So if you go for generator block, in the generator block, we do the randomization, right? So what we are doing here, class, generator, we have created an instance for the transaction class, TR, and created an instance for the mailbox generator to driver. And if you observe 22 line, okay, what we are doing here in 24th line, TR equal to new. TR is the object for the transaction we have created is equal to new method. Mailbox also we create in the same way. Semaphore also we create in the same way, right? By using the new method. So another thing what we did in 30 line, 30 line, tr dot randomize method. We just used a randomize method here. We didn't use any dollar random for each variable. Okay, we didn't randomize anything for each variable. Just we did only randomize method for tr. Okay, so what is the output for that? TR in the sense it will go directly to the transaction class, and all these variables, even it is a 12 number of variables or 100 number of variables or 1000 number of variables, or all variables will be randomized using this random method. That is the main benefit of object oriented programming. Okay, but if you go in Verilog, if you see there, so if there are 100 number of variables, 100 times we need to write the dollar random. But here, by using one object, by using through the class, okay, we are just using the method, randomized method. So all the variables will be randomized. Whatever the variables are randomizing, we are putting into the mailbox here. Okay, gen2 drive is the name of the mailbox dot put of tr. So whatever the tr data, whatever the transaction data, all the inputs will be put into the mailbox. Okay, so whatever the transaction data, all the inputs and outputs, if you write a random for outputs, outputs also will be randomized. Okay, not only inputs but outputs we should not randomize, right? That's why we kept rand for the inputs. Okay, is it clear up to here?
Yes, ma'am.
Ma'am, for random, ma'am, for randomization, we are using rand schema. Then why here we need to randomize by using tr.randomize?
Why we need to use?
This randomized method, ma'am. Here.
Hmm.
Like already we in transaction class we wrote that rand c variable, rand c. So it will randomize now that variable.
Can you write your doubt in the chat box? I'm not able to understand your voice.
Ma'am, one more question.
Hmm.
What is the difference, like you said before, difference between mailbox and FIFO, right? What is the main difference?
See, mailbox means here how we are communicating, component to component we are communicating, right? Generator to driver. Generator to driver is a component and component. Like if you take a queue, by using the queue, we cannot communicate with one component to another component. Okay. Like FIFO also same. Did you understood?
For example, if we'll use a FIFO, generator can push some data into FIFO, and then the uh, driver can take whenever it wants.
Yeah, FIFO is used. In UVM, we use the FIFO. In UVM, there are TLM ports. In there, we use the FIFO. But here in SystemVerilog, we are not using the FIFO. We use the mailbox.
So that is like the language construct.
Yes. So in transaction class, already we used RANC to randomize the variables of transaction class. Then why again we use the randomize method? See, by using the randc, it doesn't do any randomization. We are just declaring with that variable. Okay, by using the random method, this is the main method. Randomize is the main method. Whenever you call that method, then only it will do the randomization, okay, of that particular variables. So by using randc, that is just declaration. Declaration is different, creating is different. Suppose here in fourth line, I have used rand transaction tr. Okay, tr is the just a declaration of the object. Okay, so in the 24th line, I have created the tr equal to new. So creating is different. Whenever you created that object, then only you can store the data. Then only the memory will be allocated to that TR object. Okay. Here, if you tell like I have instance I have created, I have taken the instance, then I can allocate the data, means it doesn't possible. Instance declaration is where different. Here creating the object is different. Whenever we create, then only we get the memory will be allocated to that, like that. Here in transaction, we are just declaring with a rand, but calling the by using the randomized method, then only it will do the randomization. Okay, is it
And
clear?
so all the variables, uh, so which variables which are declaring with rank C, only those variables will
Mm,
randomize, right?
yes,
Okay, okay.
that's why
Other variables will not
will
randomize,
not
right?
randomize. That's why only for inputs we use the rand. Our outputs we won't use the rand. So here there are two types, rand and rand C. So the difference between rand and rand C, all these things we'll discuss later. Okay.
Okay.
So here in the generator class, we are putting the data into the mailbox, and in the driver, so this is the driver, right? So in the driver, we are creating another instance for the transaction class and creating the mailbox. And here we are getting the data from the transaction class. 45 line, if you observe 45 line. So here we are getting the data from the transaction class. Okay. Like that monitor scoreboard also same. Okay, so now we'll move to the interface again. Okay, I will tell you just theory you also can learn, right? So theory, just go through the theory and all. I will tell you the conceptual wise mainly. Okay, so in the interface, why we use the logic data type, you understood, right? So this is the normal interface. Normal, it is a static in nature. Okay, but is this interface used to communicate with the classes? Is this interface used to communicate with the object-oriented programming? Because those are dynamic in nature, but this physical interface is a static in nature. Okay, so normal interface is doesn't use to communicate. That's why we are creating one virtual interface here. Okay, so by using the virtual interface, we are going to communicate with the DUT. Okay, so how can we create that virtual interface? So if you observe here, interface calci if is the name of the interface. By using that instance name, we are creating the virtual interface. Go to the driver. Okay, because from the driver only we have the connection to the DUT, and from DUT to the monitor we have the connection, interface connection. For generator and scoreboard, there is no interface connection, right? So that's why in the driver and monitor, we create the virtual interface. Okay. So if you see here, fifth line. So we have created the virtual interface. So how we have created the virtual interface? The name of the normal interface is a calci if. By using that calci if, virtual cal if is the name of the virtual interface. Okay, that is how we create the virtual interface. Okay, now you need to observe how we will access the signals from the interface to the DUT. Okay, so now if you go to interface again, in interface there will be clocking block and the mod port. Okay, so you can go through the theory concept here. So what is meant by clocking block? Clocking block is mainly for used for the timing synchronization between driver to the DUT and DUT to the monitor. And like say mod port or use it for mod port signal connection between driver to the DUT to the monitor. Okay, we'll discuss clearly here. So what is the difference? So can you please join for the next session quickly, everyone? With the same link, please join again.
Okay.